Hi, in this video, I wanted to talk about something that I believe is important when looking at equations. This first one here is called a linear equation. The second one is quadratic equation. And this third one is a radical equation. So we have three different types of equations here. And I'm actually gonna start with this third one. So from our last video, you should know what this actually means, like from the definition. From the definition, it means what is that number? Let's call it y. What is that number when raised to the second power equals x plus 4? So just from the definition, we got to this. And this equation is asking us, or rather, sort of asserting that x minus 2 is that unknown y when raised to the second power will result in the radicand x plus 4. So if we just write that down, what that equation is saying is when this is raised to the second power, it's gonna result in x plus 4. Now notice what happened here. This is the same thing that would have happened if you just wanted to get rid of the square root sign by squaring both the left hand side and the right hand side, right? But we got there from a different way. We got there from just the definition itself, right? And what about for number 2? So now here you could also just without thinking try to get rid of the squared by taking the square root both sides, right? But you can also do the similar kind of definitions-based reasoning. Like this is asking what is that number when squared equals 9, right? So, and that number is 3, right? So this gives us a way to sort of think about this equation in a more simplified way, because 3 squared is equal to 9, in the context of this specific equation, it would mean x minus 1 would equal to 3, and then we can solve for x that way, right? So just from the definition, we could get it to this and then to this, instead of just applying the inverse operation on both sides. Now, what about for the actually first one? This is the simplest sort of type of equation, linear equation, but this one is actually hard to think about. You know, what is it that this equation is asking or saying? It's kind of hard. So, and the reason for that is because we haven't yet put this equation into a form where we can ask the natural question about it, or a statement, make a statement like these two other cases. Now this is saying what is that number that when multiplied by 2 results in 4, and we find that x is equal to 2, right? So all these equations has some sort of a question or is making a statement. So I wanted to really show you that, because that gives you a way of looking at these equations in a more intimate way, rather than simply isolating x to solve for x, which you know how to do, but maybe you don't have like more intimate idea about what you're doing. But by this, now you can think about these equations in a more familiar way. Now, the reason why we could like make a statement about number 3, even though x appears on both sides, right? So it looks complicated, has to do with the definition of the radical itself. It includes this right-hand side in sort of its definition. But for number 1, it really, like as it is written like this, it really doesn't. It's not in a form where we can ask the same sort of question as 2 or 3. So, but if we just combine the x's and combine the numbers and get to this form, but notice we haven't yet solved for x. We haven't done this yet. But if we just phrase it like this, then we know what question this equation is asking. Okay, I hope that helped you get familiar with equations a little bit more, and I'll see you in the next video.